Let's prove the induction formula using mathematical induction. The induction formula is a formula that you use in trigonometry. So we want to prove this following equation. Cosine of x plus n pi is equal to negative 1 to the power of n times cosine x. N is a integer. Let's first check what happens when n equals 1. When n equals 1, we have cosine of x plus pi, which gives us negative cosine x. And we know that this is negative cosine x because whenever you add a pi to the cosine of an angle, you always get the negative of it. Because look, if I showed you on the unit circle, here you have an angle theta. And this is your cosine value for angle theta. But then when you add pi, which is half of a circle, to this angle, so you rotate it, so now the angle's over here, the cosine is still the same absolute value, like it's still the same distance, but it's negative. So this is why when you add a pi, you get negative cosine x. And when we look at the right side of the equation, we see we have negative 1 to the 1th power. And this makes sense because n is equal to 1 times cosine x, which is equal to negative cosine x. So as you can see, when n is equal to 1, both sides of the equation is equal. So when n is equal to 1, this formula holds true. That was our first step in doing mathematical induction. Our second step is to assume that when n is equal to k, the formula cosine of x plus k pi is equal to negative 1 to the kth power times cosine x is true. And k is a integer. So then, building off of our assumption, we can go ahead and try to prove that what happens when n is equal to k plus 1. Because if we know that for any integer k, this equation is true, then it means that when you always look at the next term after it, it's always going to be true. So it's like, if the first term is true, then q, k plus 1, will be true. And then if q is true, then the next term will also be true. And if q1 is true, then q2 will be true. And if q2 is true, q3 will be true. So then this logic keeps going on and on. That's what mathematical induction is. So then when n is equal to k plus 1, we can rewrite the equation as cosine of x plus k plus 1 pi. Whenever you see a n, you replace it with k plus 1, is equal to negative 1 to the k plus 1 power times cosine x. And on the left here, we have x plus k pi plus pi. This is the same thing as, because we have an added pi here, we can move this out and make it a negative sign. Negative cosine x plus k pi is equal to, this we have a negative 1 to the k power times negative 1 times cosine x. And as you can see, we have a negative 1 on both sides of the equation. So we can get rid of it. And we have cosine of x plus k pi is equal to negative 1 to the k power times cosine x. And when we compare what we have here to what we assumed to be true up here, we see that they are identical. And because this is already true, then this conclusion, after we simplified it, is also true. So if this final equation is true, it means this equation is true, which means that this original assumption, when n is equal to k plus 1, is also true. This means that we have proved the induction formula of trigonometry. Cosine of x plus n pi is equal to -1 to the nth power times cosine x.